So, what is the scientific method? Well, when you think of the scientific method, we generally speaking use three research strategies, which I'll get to, but we use both deductive and inductive reasoning. And what I'm going to talk to you about is starting with a funnel, a broad funnel, and getting to a fine point. This is what we refer to as deductive reasoning, starting with a theory, formulating a hypothesis, and then collecting the data. So I said it's a funnel, starts out broad and comes to a fine point. So the broadest sense is a theory. So a theory is a general set of principles that allow us to organize or predict behavior, right? Based on some past observations or principles. So that's a theory. It's very broad. A hypothesis is taking the principles of a theory and applying it to our research. Now, a hypothesis is a testable prediction that oftentimes follows that theory, is guided by that theory, and sometimes our hypothesis is trying to support the pre-existing theory. Sometimes our hypothesis is trying to expand the theory to other areas. Sometimes we are using our hypothesis to pit one theory against the other to come to some conclusion which theory is more correct than the other. And sometimes we're using our research or hypothesis to reject an existing theory. So when we do our research, we're testing our hypothesis. And as I said, sometimes we're trying to support, extend, pit one theory against the other, or reject an existing theory. That's what we do. Now, as I said, the research element is when we collect the data. The data, whether it be observational, correlational, or experimental, is how we test our hypothesis. And if the results of our data are consistent with our hypothesis, then our hypothesis is supported. If the data is inconsistent with our hypothesis, then our hypothesis is rejected. Notice in science, we don't say anything is ever proven, because there could be new information that turns this theory on its head. It could further research could reject an existing theory. So that's important to understand. Now, all of this is the principle of deductive reasoning, starting with a theory, moving to a hypothesis, and then collecting research. I mentioned to you there is another model called inductive reasoning. Inductive reasoning, you start by collecting the data, and then you develop your theories after the fact. Now, which approach do you think seems like a better approach to science? Using the deductive reasoning, starting with a theory, hypothesis, research, or starting with research data and then forming a theory later? Which approach do you think is better? Anybody have a thought? Alex Santos. Alex, what do you think? Alex, are you with me? Yippo, what do you think?
Sorry?
Which approach do you think is more accurate? Deductive reasoning or inductive reasoning?
Uh, I'll say deductive.
Can you tell me why?
Deductive.
Okay. I'll go to Hagar. Hagar, which do you think is more accurate, deductive or inductive reasoning?
Modern
So what is
deduct.
the difference between the deductive and undeductive?
Yeah, so as a reminder, deductive reasoning, you start with a theory, formulate a hypothesis, and then collect the data. You start broad, like a funnel, and come to a fine point. Whereas inductive reasoning, you collect the data first, and then you formulate theories based on that data. Which approach do you think is more accurate? And I know I have some hands up, so I'll go to that afterwards. But what do you think, Hagar?
Is it deductive?
Okay, tell me why you think that.
Because first we collect it and then at the end we see our um data, or how do we do it before?
I'm not sure I understand. Jenna, what's your position?
I was gonna say inductive because, like you were saying, like you form like a specific observation and then after you form a general like conclusion. So I feel like if you're looking at it from that point of view, I feel like I would mostly lean towards that one because you collect all your data and then really know um
Gotcha.
like get a better understanding of the topic, and then from there your conclusion will be more broad and
Gotcha.
make more sense.
So if I could summarize your position, because it's data driven, you're picking inductive reasoning. I gotcha.
Yeah.
Um, Selvia, what's your
Um,
position?
I agree with Jenna, but I also think that since the deductive is more broad, so it's gonna be easier to find a theory after you've done the research than it is like to develop a broad theory and then test it out and hope you get a good research.
Okay, right on. I got that, right? So again, just saying, hey, it makes more sense to collect the data and then formulate the theory after you have all of that data. Okay. James?
I think deductive is just way more like not only just logical, but I feel like you'll get a more precise answer through that as
So
you're taking steps to really trickle in all and like filter through information.
beautiful, right? So that's the other side of the argument is the logical progression from theory, hypothesis to research. You're filtering and distilling, right? So I think I have a position on both sides, right? So when those people who believe inductive reasoning is better, it's because it's data driven and it's easier once you have the data to put the pieces together. Whereas the logic for deductive reasoning is that it's a distillation or filter process and it's grounded in a theory, right? So let me give you the final answer. Which one is a better way of doing it? The answer is it's a trap question I asked you. Both are equally valid ways to do it. Now, there are times when deductive reasoning is better. When you have a well established phenomenon, you can ground your research in theory. You can use the deductive method. However, when you're breaking new ground and nothing is known about the topic, well, then you're going to need to use inductive reasoning, right? Because inductive reasoning allows you to get that foundational data point, that foundational knowledge to be able to put it together. So the correct answer is it depends on how much is known about the topic. Well established phenomenon, deductive reasoning is the way to go. Newer ideas or less established concepts, inductive reasoning is the way to go because you need those foundational pieces. And I think it's a good point for us to say, don't fall prey to the trap questions, this one or the other, right? We fell prey to nature versus nurture. Are we born with knowledge or do we acquire knowledge through experience? And it was a combination of both, right? And now, which is better, inductive or deductive reasoning? The reality is that both are equally valid and important ways to collect data. And check this out. When we have deductive reasoning, it's still possible that our data contradicts the existing theory, which forces us to re-examine the theory as a whole, right? So even if you're using deductive reasoning, that outcome forces you to re-examine your data against the existing theory. Or the same thing, if nothing is known about a topic and you have the foundational information, well, the next piece of research is going to use your findings as the basis of their investigation. So believe it or not, deductive reasoning leads to studies with inductive reasoning. Inductive reasoning studies lead to further studies of deductive reasoning. And it's like a circle. So that's the answer. Both are equally valid based on how much you know about the topic. All right. Now, I said to you, there are 3 general research methods that we use in order to do science. So there are observational strategies, correlational strategies, and experimental strategies. And I'm going to define these so that when I go through the subtypes, it makes sense. So observational research, the goal is to describe behavior, right? So describing what you see or what your findings are. Correlational research, while you can describe behavior, correlational research allows you to also predict an outcome. So correlational research, you're going to be able to predict behavior. With an experiment, you can describe and predict, but it also allows you to determine cause and effect and explain behavior. Now, it's interesting that these 3 research methods allow us to do 4 different things. So observational research, you could describe. Correlational research, you can describe, but the new thing is you can predict. Experiments, you could do the previous 2, but the new things are determine cause and effect and explain behavior. So what's the difference between describing behavior and explaining behavior? Anyone have a sense of that one? What's the difference when you're describing behavior versus explaining behavior? And I promise this one's not a trick question. Joseph.
I think when you're describing behavior, it's it's more of you just like saying what you see.
Good.
Basically, it's like an opinion of your own that's formulated.
Or it's describing what you see, right? Versus, it may not just be an opinion, it's describing what you see. Versus explaining behavior is what?
Okay, so then explaining behavior wouldn't it be a little bit more broad?
Okay, tell me more.
Can I think a little bit more on this before
Sure.
I respond? Okay.
Jenna has her hand up, so we'll go to her, and by all means, Jenna.
I would say like describing behavior is kind of um like you were saying before, it's you're kind of just like describing like the emotions like that person's going through, but then I feel like maybe like explaining behavior is like explaining kind of like why they're going through that, or like why
Good.
maybe
Good.
like they feel the need to be like that towards people.
Good. Okay. I heard what and why. And that is the distinction. So when we describe behavior, we're saying what we see. So observational research allows us to describe what we see. When it comes to experiments, we can explain why there is the relationship there is. So it's a question of what versus why. Now, you can only explain why a phenomenon occurs the way it does if you know causal relationships, cause and effect. So the why requires an experiment. Does that make sense? Explaining behavior requires an experiment. All right. Well done. Thank you for that. Now let's talk about describing behavior in a little bit more depth. There are many ways we can conduct research to describe behavior. The first is a case study. Now, the term case study refers to an in-depth analysis of an individual, right? So we usually study an individual that's noteworthy or atypical. So let's say I'll use an example in history. Jeannie, right? Jeannie was a person who was discovered at about 11 or 12 to be completely nonverbal with absent of language. Well, that's an unusual experience, right? We expect people to start to acquire language and say their first words by 1 year old. So to be 11, 12 years old and have no language whatsoever, that's an unusual case. So a person would do research on that individual, trying to get some understanding or depth of understanding about that individual. Now, it is true that with case studies, we try and take that person and apply it or learn something about the population. But one of the challenges when you take an exceptional or atypical case is you may not be able to generalize to that population. You may be able to see the exception to the rule, not the rule. Surveys are another technique that we use. So we give people a questionnaire and we ask them to answer a series of questions, whether it be about their attitudes or behaviors. The problems with surveys is everybody lies. So when you ask sensitive topics, people are more likely to misrepresent who they are. Now, so we have other methods where we can get a more like accurate depiction of who the person is, things like naturalistic observation, where we go into nature and observe what a person is doing without trying to alter or manipulate the situation. So many naturalistic observation studies are done covertly where the person doesn't know they're being watched. And the reason why it's done covertly is because if you know you're being watched, your behavior could change. So if I'm sitting in Central Park and I'm doing a research study unbeknownst to you, then you're going to behave naturally. But if I tell you, hey, come into my lab and I'm going to observe this, that, or another, you might change your behavior because you know you're being watched. So there are all kinds of considerations we have. Now, I said a case study is an in-depth analysis of the individual. Well, an individual could be an individual person, as was the case of Jeannie. It could be an individual group. So let's say I was doing research on a community that I knew very little about. I might do a case study on a given community or a culture. And ethnography is referred to as a case study of a culture. Or I could do a case study on a situation, such as the financial crisis in the wake of the COVID-19 virus, right? So I could see, well, what happened to the the banking sector, right? Now, the situation is unique for COVID relative to other financial or banking crises. So we do have to be careful about generalizing from one situation to the next because they may not be the same. Now, case studies have been used from the beginning of psychology. So Sigmund Freud used case studies to develop his theory on personality. Piaget used case studies to develop his theory of cognitive development. But as I said, when you do a case study, you may not be able to generalize because the person, group, or situation could be atypical. All right. I mentioned surveys. We give out a bunch of questionnaires. Why do surveys? Well, the simplest answer is that it's quick and cheap. We get a lot of information relatively easily. It gives people an opportunity to talk about themselves or give you a picture or a window into their world. And it's not the kind of research that you have to use it exclusively, right? You could use surveys in conjunction or to complement other research strategies as well. So it's a pretty versatile method of collecting data. Now, but you have to be careful with surveys. One of the things you have to be careful is the words, right? So surveys, we could run the risk of errors based on jargon or simplicity, double barrel questions, loaded questions, or negative wording, right? So jargon might be as follows. If I were to ask a person, in your recent myocardial infarction, did you have hypertension? Well, because I'm using jargon, I run the risk of losing people. And phrasing the question that way, people may not understand what I'm saying. And what we found is that in general, questions should be written at roughly a 5th grade reading level. And I know that may sound insulting because your reading levels are greater than a 5th grade reading level, but the average person has roughly a 5th grade reading level. So using jargon, using very technical words, using words that are unfamiliar to the general population, you're going to lose people. And people are still going to feel pressure to answer your question, but they're not going to be able to answer it accurately because they don't know what it means. So the question I asked is, in your recent myocardial infarction, did you have hypertension? Wouldn't it be better, say, in your recent heart attack, did you have high blood pressure? That's the same question, but phrased in a more simplistic way. Another mistake that people make is a double-barreled question, which is when you ask 2 questions at the same time and only leave the opportunity to respond to one. So if I were to say, and I'm going to take the most extreme scenario, true or false, right? That's the response. And I give a person the following question: I like ice cream and killing puppies. Now, that's an extreme example, right? Because we would expect the average person to say true to I like ice cream. And we would also expect a person to say false to liking killing puppies. But if you can only pick true or false, then which one were you saying true about? Right? I asked you 2 questions, and I cannot infer what was true, what was false. So it's a common mistake. And when we develop questionnaires, we have to review them to make sure we don't ask 2 questions at once. What is the solution? Is to separate them into 2 individual questions rather than one question that has 2 parts. Now, another thing that is problematic in surveys is the issue of loaded questions. True or false? Dr. Kaplan should let us out early from class. Well, as students, I would assume as much as you enjoy the lecture, you would probably prefer to get out early, right? So that's skewed in a way to force you to say true because you want to get out early. Another issue is what we call negative wording. Anytime you use the word except, not, right? It negates the statement. Do you think we shouldn't be in Iraq? Yes or no? Well, you're supposed to phrase all your questions in the positive, right? Because when you use negative wording or negative questions, you can confuse people and people are going to make a mistake because they have to understand the question and flip it backwards, right? So when we were in the war in Iraq, if I were to say, do you think we should be in Iraq? That is a lot easier of a question to answer than the negative wording question, do you think we shouldn't be in Iraq, right? Because of the wording get confuses. Now, we also have to think about surveys in terms of how much of a sample we're going to do, right? Because when we give out surveys, we don't usually give it to everybody. We collect data on a subset, right? So we want to use our survey to generalize out. The election's coming up, and there are going to be pollsters that give out surveys, right? And they're going to use maybe 1,000 people and try and guess what America's voice is, right? So the population would be America as a whole. What does America want? And then the sample would be the subset that you collected data. And with 1,000 people, you could guess what 330 million people want. And that's a beautiful principle because when we give surveys, they don't have to be crazy large. The samples can be roughly 1,000 can generalize out to the population. So better than a large sample, it's better to have a representative sample. And a representative sample is when your sample reflects the population as a whole. So it's a miniature version of the population. I know that we have a lot of digital photography today, but those people who still use film, this is the best way to describe it. The film itself or the negative itself is the sample. When you blow up the picture into a larger picture that you can hang on your wall, that would be the population. So the population is a larger depiction, but notice the film has all of the elements of the picture you hang on your wall. It's just a smaller version. So samples should be representative. Now, there are two ways to make it representative. One is using random sampling, and that gives everyone equal opportunity to participate. So it doesn't have a biased, larger proportion of this group. Everyone can participate. The other thing is if you're worried about distribution, we can use something called stratified random sampling, which is that we force our sample to match the population. So if there's X percent in the population of this community, then in our sample, that same percentage has to be reflected. And when we recruit, once we have that percentage, we no longer allow more participants of that group because we want the sample to be as similar to the population as possible. Now, before I talk about naturalistic observation, the other issue with surveys is that people lie. People lie all the time on surveys. So if you were to ask a person a question related to substance use, it's a taboo. Sexual activities, taboo. Even divorce in some communities can be a taboo. So people are going to misrepresent their answers on surveys. Now, naturalistic observation was another observational strategy. Notice we're going to go into nature and make a direct look as to what is happening, right? So we're not trying to alter what is happening. But when we go into nature, we stay there for an extended period of time, maybe 6 months, a year. And every day we write in our field journal and we look for patterns of data. And those patterns become our description of what's happening. In many ways, a naturalistic observation operates similar to inductive reasoning, right? So it uses that strategy of collecting the data first, then analyzing and identifying themes. So, but for a naturalistic observation to work, you do have to stay in a setting for an extended period of time. That's why some people don't like it, because you may be away from your family for 6 months to a year. Now, when you're doing naturalistic observation, the question is, do you participate or not? Well, that's a debate. But the benefits of participating is you have a first-hand experience. You assume an insider role of what's going on. People, as you participate, might level with you. The problem is that it's harder to become or stay objective, because as you're participating, it may cloud your vision or your perspective, right? So that's the cons of participating. So when you're a non-participant, you do not become an active part of the setting. Now, not being a non-participant, people are going to act more natural, oftentimes, but you may not have that first-hand experience, so you might miss data from that first-hand point of view. Now, I'm going to stop there for today. We'll talk in another video about correlations and experiments. There'll be separate videos, but this seems like a good place to stop for today, and I'm going to take attendance another time.